So, we now come to the part 3, the third part of smart cities and smart homes, and unlike in the previous two lectures where we focused mostly on smart cities, here in this particular lecture we are going to focus on smart homes. So, when we talk about smart homes, we are talking about the integration of ICT technologies like the ones that I mentioned as part of the previous two lectures, or even the ones that we spoke about throughout in this course, taking help of these different technologies, how we can make our homes smart. So, let us consider a scenario like this. So, we have let us say a smart home. In a home, we have different rooms, we have let us say, let me just, for simplicity, let me just denote these different rooms here, here, and so on. I am not, as you can see, I am not very good in this art, particularly when it comes to 3D pictures. So, let us say that this is room 1, this is room 2, then you have a kitchen, then you have the washroom, so in a smart home you have different sensors that are basically deployed in different places, and at the same time you also have some actuators as well. Let us say that these are the different actuators, which could be even some would be in the room itself. So, you have different sensors, actuators, and different types of other like NFC devices or different other IOT devices, and they talk to each other. So, let us consider that we have in a smart home we have to do something better. So, do what? Let us say that we have to cook something in a better manner. So, what can be done is from a particular room where we are sitting. So, from that point on there could be some kind of a device which can go and which can go to the kitchen, and from the refrigerator of the kitchen it can take out something, and then in the kitchen there is a microwave device. It is going to put that in the microwave device, then it is going to boil it, or it is going to warm up in the microwave oven, and then it is going to serve me, right. So, this is one example. Like this, there are different other things at home, the different activities that we do at home, these could also be made smarter. So, this is an example of smart home. In smart home you need better health care, improved activity, improved activity, I would say that performing, and so on, like this. So, whatever regular activities that you do, those can also be improved, so that the activities can be done efficiently. So, going back, let us look at the smart home infrastructure. So, you need these different infrastructure. These infrastructure, as I was telling you so far, that you have these different sensors, actuators, different robotic devices that are there at your home, and also you need the networking infrastructure. So, you have intelligent networking device infrastructure. There is seamless integration of these various devices, the sensors, actuators, etc., using wireless, typically wireless technologies are used, but wire technologies could also be used in addition. So, this basically allows the use of household systems. So, improving the efficiency of performing different activities in a smart home, or the use of these different household systems can be improved. It creates a highly personalized and safe home space. So, whatever I need, I can do things efficiently, and why it is efficient, because let us say that if I have run out of the groceries, the grocer is going to be informed, so that will make it more efficient. So, corporations like GE, Cisco, Google, Microsoft and many others, they are seriously thinking about building smart home systems. They are seriously thinking about, they are investing on building smart home systems. So, smart home systems have become very popular in the recent years. So, smart home basically provides productive and cost effective environment, because if you are doing things efficiently, the cost is going to improve, is going to reduce. So, it is going to be cost efficient, maximizes the effectiveness of the occupants, provides efficient management with minimum lifetime costs of hardware and facilities, and optimizes things such as structures, systems, services and management, interrelationships between the above three. So, all these are going to be optimized in a smart home environment. So, in a smart home, basically the different components are sensor networks, sensor networks, intelligent control, intelligent management, communication network infrastructure and smart features and automatic responses. So, in a smart home, we are typically talking about something known as home area network, which is analogous to something like a local area network in a building or couple of buildings together. When typically we have these local area networks. So, and then we have this personal area network. So, personal area network is very much like small in terms of the range. Typically human bodies have the personal area networks, or then we can have these personal area networks out of these different peripheral devices in a computing system. So, personal area networks is too small, then the local area networks are much bigger, then we need something in between for use in smart homes, and this is known as the home area network. So, in the home area network, we have different components. We have these home area network elements, which we are going to talk about in more detail shortly. So, the network is basically contained within a particular home in a home area network. Then we have these different standards, the architectures, then we have the different initiatives. So, basically so we are going to talk about each of these in further detail with respect to the home area network elements, home area network standards, home area network architectures and the different other initiatives we are going to talk about shortly. So, the network is contained within a home. It enables the remote access and control of devices and systems, and provides amalgamation of various systems within a home, such as security system, home automation system, personal media, communication and so on. So, let us start with the home area network element. The first one is IP protocol. So, we have multi protocol gateway bridges the non IP network to IP network. In other words, so you have in a home area network support for both IP based networks, the traditional internet based networks, as well as there are some non IP based networks as well, and there are gateways that would bridge multi protocol gateway. That means support, those gateways basically support, they understand the language of different protocols, both IP based protocols they understand, as well as the non IP based protocols, both they understand. Bridging between new technologies is limited with the help of IP based IP based protocol, and for new technologies or networks, a new mapping is required for bridging to perform satisfactorily. The next one is the wired home area network. So, this basically enables easy integration with pre-existing house infrastructure like existing telephony systems, existing cables, cable television cables and so on. So, easy integration is possible with the help of this. It is low cost because you do not need additional wiring, additional infrastructure, with the help of these existing systems it can be done. And this is cheaper, but at the same time it has different limitations. It has different limitations because mobility is one issue. So, if it is all wired, you cannot move around, and mobility is very important. Ease in mobility is very important in a in a smart environment, in any smart environment, and in a smart home as well. So, although wired technologies in a home area network are less expensive compared to the wireless counterpart, but at the same time it also restricts the mobility of the users at home. Wireless home area network uses different technologies like Wi-Fi, Zigbee, and the different others that we spoke about in this course, the earlier part of this course. For example, the ones that we covered in module 1, the different technologies, those can be used for wireless home area network. So, wireless makes implementation easy, it improves the mobility of the users, thereby improves the satisfaction and the utility of home networks. Overall this utility is going to improve. So, the classification of home area networks. So, we have the home area network communication and networking technologies which are wired or wireless. Wired would take help of electric lines, telephone lines, optical fibers that are already existing at home, even the cable television cables, cable TV cables and so on. Wireless basically are typically battery operated, or they can even be battery free, and the battery operated, there is no energy harvesting. In battery free there is energy harvesting, and some of these protocols that basically help in this battery operated energy harvested communication in a home area network are given over here. So, we have Z-Wave, Wi-Fi, 6LoWPAN, Zigbee and so on. In-ocean basically harvests energy and it is battery free wireless technology. Now, the different standards that are supported, we have the most important one, the most popular one, the UPnP, Universal Plug and Play. Universal Plug and Play is a protocol standard that is used typically in most of the smart environments and particularly for building smart homes. So, Universal Plug and Play is an application layer technology, particularly for web based applications it is used. So, the TCP/IP protocol stack provides support for the lower layers and enables seamless integration of the various technologies, and provides the transparent networking with support for zero configuration networking and automatic discovery of services. Then we have the DLNA, the full form of which is Digital Living Network Alliance, DLNA. It is a trade organization that is created by companies like Sony, Intel and Microsoft. It connects cable based networks with wireless networks for increased sharing of media, control and access. So, cable networks come up with lot of media content, sharing those with the help of other wireless networks with the users. So, the DLNA, Digital Living Network Alliance, basically this helps in this kind of content being made available, the media rich content being made available in domestic front for use by the domestic users at home. Then we have this CONNEX standard, in short it is also known as the KNX standard, which is an important standard for home and building networks, which utilizes the full range of home communication infrastructure, including power lines, coaxial cables, twisted pair, RF, etc. Whatever is existing, those existing infrastructure, the communication infrastructure are utilized in CONNEX, and this must be set up and configured via a software before its proper usage. Then we have the LAN works, local operation networks, LAN works. where every device includes a neuron chip. LearnWorks has the different devices which include something known as the neuron chip, which has a transceiver and the application electronics. So, the neuron chip is a system on chip with multiple microprocessors, RAM, ROM, IO interface ports and so on. It splits the device groups into intelligent elements which can communicate through a physical communication medium. Then we have the ZigBee, and ZigBee we have actually discussed in a lot detail in module 1. So, I am not going to talk about in too much detail here, but from a home area network perspective, ZigBee is very commonly used. It has the different layers, the physical layer, the MAC layer, the network layer and the application layer, as you already know by virtue of your existing knowledge of ZigBee in the module 1 of this course. Physical and MAC layers in ZigBee are defined with the help of the 802.15.4 IEEE standard, whereas the network and application layers are defined by ZigBee itself. It aims at low cost, low energy devices, and there is a ZigBee alliance comprising of companies such as Mitsubishi, Honeywell, Invensys, Motorola and Philips. So, this basically guides the development of the ZigBee standard forward. X10 is another standard that enables remote control of compliant transmitters and receivers over power lines and electrical wirings that are already present at home. It was adopted by GE and Philips, and this standard defines the procedures for transmission of bits over AC carrier, alternating carrier current carrier signals, and it has low speed and low data rate and is mainly used for control of lighting, appliance networks and security sensors. Now, let us talk about in brief about the different home area network architectures. The home area network architectures, two of them are quite popular. The first one is the DOMONET, which uses XML for description and web services for control, follows a service oriented based architecture, and it is not tied to any specific type of software, language or architecture. Here in DOMONET, a central gateway is there which connects different technologies, and there is also a tech manager for each technology that provides the web services for control and access. Then we have this Genie architecture that helps in connecting various devices, sharing their resources with auto configuration and auto installation. It is based on the Java environment and is pursued by the company Sun Microsystems, which later on became Oracle. It constructs an organized distribution system without a central node. Genie applications use the bytecode and the JVM. So, this is basically Java environment compliant. That is the reason actually it is using the JVM and the bytecode and are portable, because it is based on the use of JVM and bytecode based technology. So, wherever this JVM is installed, so bytecode is basically portable technology in Java, and that is the reason Genie is also very much portable. It follows the object oriented paradigm. In terms of the initiatives, there is that Hydra project, which is about some middleware for embedded intelligent systems. So, that middleware was was proposed for use in IoT kind of environments where there are embedded intelligent systems or intelligent devices. It connects a service oriented architecture network. The connected devices may have limited resources, low processing power, memory or energy consumption. Here in Hydra, each device has an embedded Hydra client which acts as a proxy between the device and the middleware. So, in the Hydra protocol stack, there are these different layers. We have at the very bottom we have the physical layer, having Bluetooth, ZigBee, wireless local area networks and so on. On top we have the operating system comprising of TinyOS, Windows, etc. So, TinyOS is an operating system of Windows of sensors. So, it is commonly used along with the sensors. So, TinyOS operating system. Then we have the Hydra middleware, and then we have these applications. In the Hydra middleware, we have these application elements and the device elements, and they basically handshake with respect to these different three layers, the network layer, the service layer and the semantic layer, and there is a vertically cutting across security layer in Hydra. So, this is how the overall Hydra protocol stack looks like. And then comes the other architecture, which is the Amigo architecture, Amigo initiative, not architecture, the Amigo initiative, which is aimed at ambient intelligent systems for networked home environments. Amigo basically features user friendly interfaces. It takes care of interoperability and also the issues of automatic discovery of devices and services, which are very important in IoT environments, particularly when we are talking about home area networks, home users and home smart homes. So, with this we come to an end of this lecture, specifically focusing on smart homes. We have seen the different protocols that are used in smart homes, the different architectures of smart homes and also the different initiatives, the Hydra and the Amigo initiatives that use that these initiatives are there for building smart homes. Thank you.